This is lesson number 78 in Algebra 2, force vectors at a point. And we have done things similar to this in previous lessons. Golly, now that I say that, trying to remember exactly which lesson it was and if it was even this class we did it. I thought it was this class, but maybe it wasn't. Anyway, regardless, there is a picture. And what we've got here is let's just say we've got a weight here. Okay? And when we've got that weight, we have somebody pulling this direction, say 70 pounds of force that way, and somebody pulling 40 pounds of weight that way. Well, the resultant is that this thing will go up. It's just not going to be very easy to make go up. Now, if we had a weight here, and we had a rope here and a rope here, and two people were pulling these ropes here, that would be easier to lift up than if we've got somebody pulling this way and this way, because even though you're pulling 70 pounds, some of it is pulling up, but some of it's pulling this way. And the same here, 40 pounds, some of it's going up, some of it's going this way. So, gosh, I hope that makes some sense to you as far as what's happening there. But what we're looking at is we're looking at the resultant force on this point right there. So what we do is we draw two triangles. So we take this and make it into a triangle, and this and make it into a triangle, and we find the resultant force. So basically we're going to take the information here and add it to the information there, and that will give us our resultant force, and that's what we're going to be looking at. Okay, so what we have here is we took this little drawing here that I'm erasing this green junk from, and we drew it as two separate triangles down below. So see how they connect? We've got a 70 and a 45 and a 40 and a 30, just like we do here. Alright, let's move this out of the way. So that's the first thing you're going to do, is you're going to make two triangles out of the picture they give you. Okay, so what we're going to do first is we're going to find the length of B. Now if you remember right, when we find the x value, we take the hypotenuse times the cosine of 45. Yeah, I know we did this in an earlier lesson. Okay, and when we do that, we get 49.5-ish. And then when we do A, we take 70 sine of 45, and when we do that, we get 49.5. Okay, we get the same because this is a 45-degree angle, and it's a triangle, and this side will always be the same. Alright, so let's do this in green. We'll find C. C equals that hypotenuse cosine, because it's the x, of 30 degrees, and that equals 34.6-ish. Alright, let me, before we go on, let me make a change here. If you look here, let's see, I'll leave that there. I'm going to bring this picture back down. Notice when we have this here, this is always going to be the origin. Our x is this way, so our x is negative, our y is positive. Our x is positive, our y is positive. So this here is a negative direction. So that being the case, get rid of all this. Our b here should be negative. So let me go ahead and make that b negative here. And I didn't do that. I forgot to do that. Alright, my a is going up, so it's a positive. And move my drawing back over so it fits there. My c is positive, and my D is going up, so it's positive. So my C and D are both positive. And that's going to be 40 sine of 30 equals 20. Okay, so the book doesn't show that this is a negative right here. I'm not really sure why they're doing it the way they do, but it is a negative. And they do make it negative later on, but they don't explain why it turned negative or anything, and so hopefully that'll help you understand. Alright, so what we have to do now is add our x values, and I will circle those in yellow. Our x value here, we need to add that to our c value, or our other x value, because this one goes with that and this one goes with that. So we're going to add those two numbers, and when we add those two numbers we're going to get a negative 14 point, let's see, 49, I have no calculator with me, so I'm just going to write down the answer the book has, even though theirs a little different than mine because I rounded differently than they did, but we'll just put their answer down. So that's our x value, negative 14.857r. Alright, so let's do the y values in blue. So there's my left y value, there's my right y value. And so I'm going to add those together. So 49 and 20 is 69.5 up. So there is my resultant in rectangular form. Now it does not say leave it in rectangular form, it does not say change it to polar form, but let's go ahead and change it to polar form just so you can be reminded of how you do that. So here's our answer in rectangular form. So what we're going to do is we're going to make that into a triangle. So it's going to be a triangle that has as its up 69.5, and as its x value it's going to be 14.86, negative 14.86. So I've got this line here and I've got this here, and this is negative 14.86, which is just that rounded. Okay, and there's our origin. So I did put my origin there, and I went over 14.86 and up 69.5 to get to that point that I'm looking for. Alright, in order to write that triangle, or write this answer here in polar form, I have to find the hypotenuse, and I have to have this angle. Okay, so I'm going to use my x and y that I have here in order to find the hypotenuse and the angle that I'm looking for. Okay, so I just slid everything up so I'd have more room to write. Alright, so how do I find the hypotenuse? Well, we can find the hypotenuse using the distance formula. So we can say that the square root of 69.5 squared plus 14.86 squared. Notice I changed it to a positive because length is not going to be negative. That negative there just showed me what direction I was going. And it wouldn't matter if you made that negative. When you square it, it's going to be positive anyway. And that will give me my hypotenuse, or my force, actually, my F. So my force then is, when I'm done, 71.07. So this is 71.07. Now I have to find my angle. Alright, this angle right here, I'm going to use, in this case, I'm going to use tangent. I can really use any of my trig functions. So the tangent of theta is going to be the opposite over the adjacent. Now I could use cosine or sine because now that I have a hypotenuse I could use those. Alright, so that gives me tangent of theta equals 4.6770. Alright, then I take the arctan because I'm looking for the angle, so I'm switching things around, and I'm going to switch this with theta. I just switch those around, put a -1, plug this into my calculator, and that'll give me an angle of 102.07. So that gave me what I'm interested in. It gave me my hypotenuse and it gave me my angle. So my answer then in polar form would be 71.07 at 102.07 degrees, if you wanted to write that in polar form. So we've got the rectangular form and the polar form. So let's go ahead with the next example, and then we'll be done, and we'll put this on another video since I'm running out of time.